Thank you for having me here. This is my second time in Hungary, but the first time in this conference. I hear a lot about it. Actually, Hungary is very famous in Brazil hacking community for the reverse engineering and working, cracking communities. So I'm really glad to be here, talking to all of you. This talk is a little bit about what is mitigations, what is exploit writing, and how this is actually changing the way that big corporations are doing security, and what else we need to do, and how much we still need to do in that area to actually get better. I want to start with a very common joke. It's a famous joke on the definition of heaven and hell. And here it doesn't matter if you believe in heaven or hell. The joke still is interesting. But basically, heaven is where the police are the bridge, right? The cooks are Italian, the mechanics are German, the lovers are Brazilians. Very convenient for me putting that joke, right? And everything is organized by the Swiss, right? And hell, of course, is where you mix it all up, right? So you have the chefs as the bridge, you have the mechanics as the Brazilian, the lovers are the Swiss, and so on, right? Why I'm putting this joke? Because I want to start the talk with a disclaimer, right? And in that disclaimer, I redefine what hell is. Hell is where lawyers do exist. So I'm here not on behalf of the company that I work for. I'm giving my opinions, okay? That's what I believe and what I see in the world. Don't blame the company I work for anything that I say here. If you are a lawyer, I am really sorry in advance. But overall, in this presentation, I will be using like a poetic license, because I do believe hacking is still an art. I will discuss a little bit about that and why I believe hacking is still an art and where engineering is coming from and the importance of engineering in the hacking. I will also use a lot of generalizations in the talk. I hope that nobody gets offended by those generalizations. So if I say, hey, academia is not helping the security community, or academia is not doing a very great work in security field, that doesn't mean the entire academia is to blame. There are, of course, a lot of spots of a lot of good work that is coming from academia. I'm just trying to talk about the general case. If you are an exception, be proud of being an exception of this general case, and let's make sure we make the exception to be the rule, right? So I appreciate that understanding. I'm not here to try to tell everyone what is really security research and how security research is performed. I think the audience is much better than me in that area. And I am also not here to try to using Pocket GTFO sermon style. I'm not here to teach the priests how to pray, right? What I'm here to is to try to give a way that I use to explain and talk about security. I use that in a large corporation, I use that with friends, I use that with other security researchers. And I think if we agree in some basics and some base elements on what is security, what is mitigation, and how exploit works, then basically everything else gets easier for everybody. So I hope that I will manage to do that. Use this talk as an opportunity to have some points that you use as a baseline. You might not agree with those points, but if they come up in conversations and discussions that you have, that's more than enough, right? And feel free to challenge some of those points as well, because nobody really owns the truth, right? But if I really define the objectives of this talk in only one image, I would use this one. So this image actually was created a while back by my team when we were making fun out of security vulnerabilities in the world, right? So in the left side for you, you have the attacker opinion when it finds a bug, right? So the researcher goes and finds a bug, and he imagined that's God mode, right? He dominated the world. The bug is the most important thing ever, right? And it's interesting because we talk about that as external security researchers do it. I do it, my coworkers do it when they find a bug, even internal in a company, right? It's just normal. You want your baby to be the most beautiful one, right? And when you find something, you spent a lot of time doing it, and you want to believe that this is really important, right? And I'm not saying it's not important. I'm just maybe challenging that this is the God mode in Doom. And interestingly enough, the same group of people, when they actually proposing a mitigation, they imagine the attacker is the dumbest possible attacker ever, and that the attacker will play by all the rules that they defined for that mitigation. So it's interesting that in one side, when they are attacking, they believe the attack is the God mode. It has all the powers, all the capabilities. But when they are actually proposing the mitigation, the attacker is dumb. And it's interesting because while we had this joke a long time in our team, like Halvar Flake gave a presentation in a conference, and he came up with the mitigator. And the mitigator was essentially like this very nice animal that I will not try to define which animal is this. I will say it's a dinosaur that basically raises the bar until no more exploits can be seen, right? Because that's really the word that people, when they define mitigations, they like to say, right? It's very common. It raises the bar. What raising the bar really means, right? It's very hard to quantify raising the bar. Is this really raising the bar or not? Like, I love to see the discussions around KSLR as a great example of raising the bar, right? Every time that I see like Spender fighting someone else on Twitter, for example, when they say, hey, KSLR is very useful, even though there were only 3 remote kernel overflows and KSLR didn't help against any of the 3, KSLR is very useful. Even though there's lots of local leaks that bypasses KSLR all the time, KSLR is very useful. And then the argument, when they have known, is, but it raises the bar. And what it really means, right? So I really hope I will help define what raising the bar really is. So if you go out of this talk and you only remember 3 things, I hope it will be these 3 arguments I will give. And if you use those arguments every time someone is discussing mitigations, I will be already very happy. Even if you don't agree with the arguments, even if it's to just challenge that the arguments are correct. So I will start saying that threat modeling overall is a very mature area, right? It's a mature field. We know how to do threat modeling. It's like it's been done for many years. Big corporations know how to do it. Small corporations know how to do it. There's a lot of written documentation on the subject. And overall, people working in security understand it. I'm not saying we do it very well. I'm not saying that everybody's doing it well, but it is an area that is well understood, that is well documented. It's interesting because we know that in threat modeling, you need to define the security objectives, attackers that are in scope, for example. Does an attacker with physical presence is in scope for the given product? Physical possession, as Microsoft liked to split the physical attacks on presence and possession. Is the attack remote and privileged, and so on, right? The threat modeling overall defined for it, like what you expect the attacker capabilities are, and what are your mitigations, or what do you do in your product to keep the security of it. But even though the threat modeling itself is mature in terms of how to do it, and again, I'm not saying everybody does it very well, or I'm not even saying that most people or most companies do it very well, I'm just saying it is mature. We don't have the same mature process when defining mitigations. It's interesting because, and here I'm using mitigations to talk about not, hey, I'm patching a given bug, I'm mitigating that specific vulnerability. I'm talking more about hey, I'm putting something on my system that is a new security capability in that system that hopefully will mitigate against an entire class of bugs in that system, right? So I'm talking about this kind of mitigations here. Notice that I am also not trying to argue that the mitigations are so important and people need to consider them on top of any other quality controls in software, right? Even though you might have mitigations in place, you still should be fixing bad process and bad quality in software, right? I'm not trying to argue against that. But it is mature in threat modeling, no mature in mitigation. So what is one thing that I remember, once a mathematician, actually a professor of mine, he made a joke with me, right? Because I was doing engineering, and that professor came to me and said, yeah, the proof by induction for engineers is a little bit different than for mathematicians. For engineers, if it works for case 1, works for case 2, and works for case 3, it works for all the cases. It's obviously not what proof by induction is, but it is the way that we engineers like to see that, right? We try to use, hey, yeah, it worked for these 3 cases, it should work for everything. So what I'm proposing here is that when we talk about mitigations, let's use the proof by induction of the engineer, okay? If you say, hey, this mitigation really works against a class of vulnerabilities, then you need to find at least 3 instances of this class where there is no way that the attacker could bypass the mitigation. And it's interesting because this is a challenge. That is a valid challenge. And if you talk to people, they will say, yeah, but it mitigated this exploit instance. I'm not talking about mitigating an exploit instance. I'm talking about mitigating the vulnerability from being exploitable at all. That's very different. And that's where most of the mitigation starts failing, because they don't do this base analysis. The next argument that people proposing mitigation will use is say, yeah, but this mitigation is made to use together with this other mitigation. And it is fine. Then you can't propose only one of them. Then they need to be seen together as one. And you start understanding why, for example, PAC's team always complain about people trying to split the patches and propose mitigation separately. Because if you have a mitigation A that has some value, have a mitigation B that has another value, together, that might be a positive value. Separately, each of them might have actually a negative value. And the reason is very simple. They add complexity. And if that added complexity is not really fixing any real class of vulnerabilities, it's nothing. It's just raising the bar, whatever that raising the bar means. Essentially, you're adding complexity for no actual value. Therefore, the value is negative. So keep that in mind. And let's use the proof by the engineer formula when we're talking about mitigation. Then, we go, next point is like, there's a lot of people that are like talking about like formalization, right? Like trying to really formalize what is an exploit, what is exploitability. And that's actually a very good trend. I will talk a little bit more on that later. But I do believe this is very good because that's the way for us to bridge between what is engineering and what is currently art. Right? If we start formalizing, we start defining proofs, we start defining a method, that becomes engineering. And then like we have much more people that can help us than only the artists that are the hackers currently, right? But one important point that comes is like every time we go to a conference like this, we have amazing presentations, right? We have like some of the smartest people in our field coming and presenting very amazing accomplishments. And like we go and we watch the talk, and of course, like we understand what they're saying. Like we are smart, we can follow what they're presenting. Sometimes we will have questions we will ask, or some things that we need to ask later. But the matter is, we have some understanding. I want to be sure that everybody understands that this understanding is far from having the same ability of the person who actually did the research in the first place. And the reason is very simple. The presentation simplifies everything. It's an after-the-fact presentation, right? So basically, the researcher already did everything, and it's resuming it in a way that it fits on the slides, or in a way that represents what he or she believes is the most important points on that research. It doesn't talk about all the failures that happened, all the previous knowledge that existed. Therefore, there is an understanding that everybody ends up getting, but it's very far from being the same level of whoever did the original research. And this is important, because this is one of the main problems that we end up having, is we made offensive research being so famous, right? Everybody now wants to be a hacker. Everybody now wants to write exploits. And the truth is, this is not super fun, otherwise much more people would be doing it. This is a thing that some artists love it. I love spending my time, I love wasting my time. Even when things fail, I still get really happy in the end of the day. But not everybody is like that. The matter is, if you have a small understanding on what was done, that doesn't mean you really understood everything. And why I say that is not to try to be arrogant or anything, and I'm sure that the speakers are not arrogant at all as well, right? It's just to be sure that everybody understands that people who really know how this works, how this field works, how things break, they are rare. And we need to make them less rare, let's say like that. That's one of the reasons for formalization. But most importantly, when you're defining a mitigation, the only way you can define something that works is if you really understand how the attacks to that would work. Otherwise, you're just defining something that raises the bar, whatever the raises the bar mean. So here is something that I want to propose. Those proposing a mitigation, they must understand the problem. That understanding can be gained in two different ways, right? Either through writing real-world exploits for this class of vulnerabilities, really getting real vulnerabilities, writing the exploits for them, understand that entire class, understand that class in multiple instances that that class appears, or pairing up with someone who does. Otherwise, if that's not what you do, if that's not the field, if that's not if you don't have someone to pair up, and it's not really exactly what you do and you never did it, I recommend you to not go and propose mitigations. And if you see someone proposing mitigations, ask those questions. Hey, which exploits you ever wrote in your life or in your career for this kind of class of vulnerabilities? And the second question, if the answer is known, right? Who you paired with that actually did? And if the answer is negative for both, doubt that this mitigation really makes a lot of sense. Because probably it does not. It probably just raises the bar again, right? And this raising the bar doesn't really mean much. So, a disclaimer that is very important here. That doesn't mean everybody working in mitigation development really likes to write exploits, right? I know a lot of developers that really work in incredible mitigations, and they really don't necessarily enjoy writing exploits, but they do understand it. And they really keep up to date on how this works, and they are able to do it. So that's the main difference there. So that's the second point. And then a third point that connects back to the sharing of information, right? We researchers, when we share information, when we do a presentation, there is a lot that ends up being filtered, right? Oftentimes we filter just because of time. Oftentimes we filter because we believe we don't understand a given part of the problem enough, so we prefer to not discuss it. Oftentimes we just don't want to say things that we did that failed. There is a multitude of reasons for not sharing those points, right? But unfortunately, this also created this misperception of knowledge, right? I think there is an overall misperception of knowledge. Security is very hard and has a lot of different talents, right? We have people that can do a business risk assessment, that are things that I would never be able to do, and they're very good in that. There are people that are very good in writing exploits, people that are very good in engineering overall problems, right? Getting performance, optimizing. There's so many different problems in computing industry. So let's make sure that we don't mispercept what is the knowledge of that person, right? Just because someone is proposing something, that doesn't mean necessarily they fully understand that something. One of the common things that I see is researchers either trying to make it a little bit bigger, the impact of what they did, or sometimes the opposite. They don't even realize the bigger picture of what they're proposing. They even don't realize how this impact is much bigger than they initially thought. So it's important to keep that in mind. And that's the third point that I will make. But before I go there, let me use a phrase that Neil deGrasse created that I believe really defines it, right? As more as we know, as more as the perimeter of that knowledge grows, therefore as more as we know, we don't know. So it's interesting because when you start learning, you start realizing more and more that you don't know about some other topics because they are adjacent to what you're learning. And then as more as you have to learn. But people who don't really go as deep, they usually believe they know a lot, right? And this creates a very big disbalance. So for me, what I always try to do, is every time that I believe I had an idea that is genial, that I'm hey, come on, this is easy. What I do is first, I try to realize that the world is huge. It's full of people much smarter than me, right? So if I am the one that is having this genial idea, and suddenly it's super easy, super simple, I try to doubt. I try to make sure that I really did the proper research on the subject, that I really look into more of what is there. And overall, I find out that I was wrong. I was actually being an idiot, but I just didn't know it. So that's one thing that I recommend. So that's the very last thing. If you plan to invest in defense, you really need to benefit from the investments in defense. Notice that I'm not saying here that offensive security is more important. No, I believe that we should stop actually seeing offensive security as something super special and people doing defense as no special at all. I think we should understand that one should be driving the other. They should work together. You don't have a good defense if there is not a good offense, and vice versa, right? Exploiting the same thing again and again, there is no benefit, right? You need the art to evolve. In the mitigation space, though, this actually means that the implementation details, the actual details on how something is implemented in practice, are more important than the architectural details of it. So the overall idea sometimes looks like very trivial, right? Like, yeah, you know, like you just do this, right? Like rat pulling as a good recent example. If anybody wants to read something that like in the definition looks very simple, when you go to implement, there is a lot of complexities. But the implementation details really make a lot of difference. And why I'm saying that? I'm saying this because it's very common that we see architects defining the whole mitigation. And then designers only work to actually implement whatever the architecture defined. And I do believe this is wrong. I think there needs to be a pair up there as well. And designers need to be part of the mitigation development overall. So those were like the 3 main points. And I will go back to them. But I will use the rest of the time of the presentation to talk about like some of the elements on those 3 points. So I will start with what I miss, right? Which kind of information I believe researchers could share more. Like, and if you are a researcher, please consider that. If you're not a researcher, but you go to talks and you go to conferences like this one, try to ask the researchers for that information because they are valuable. So notice that because proper mitigation design is really hard, as I mentioned, right? It gets even harder if you don't have the data available. So getting that data, as I said, right, it's hard because either you're writing exploits for this class of vulnerabilities or you need to pair up with someone who does. If that someone is rare, and of course, it's not accessible for a lot of people that are in the academia, they might not be accessible for people that are, like, for example, in smaller companies or independent researchers. How we bring people to collaborate? We basically need to make the data available. That data is basically being made available by write-ups, for example, on Pautuan, right? Where they go, they write the full exploit, it's a full chain of exploits, and then people go and present in conference like Black Hat or some other conferences, what they did. Some people write the full blog post on it. But then usually what is missing there is how much time you actually took to do the entire research. What did you try that failed? What did you already have when you started? So for example, we overlook a tool setting, right? But then lots of researchers have a lot of tools already available because they already exploited similar vulnerabilities in a similar context. It might not be exactly the same target or system, but similar context. And they develop tools that they can use or they can leverage in their analysis. This is all inclusive in the time, right? On the time spent. So if we're talking about raising the bar, and if we want to measure what raising the bar is, we need this data. We need to understand hey, we added a mitigation. This mitigation at the time did block 3 known cases of instance of vulnerabilities. We did all this analysis. But then suddenly, someone figures out something new that we didn't know before, right? That we missed when we developed the mitigation. Now we need to go back and see, hey, should we still keep this mitigation in place or it lost fully the value? Can we just kill these new methods, or no, we need to reconsider the entire mitigation? One thing that I notice is mitigation becomes legacy in all systems. It's very rare that I see someone saying, hey, we're removing this mitigation because now it has no more value. We learned so much more about the features, so much more about the system, or the system grew so much in complexity that the given mitigation now is not necessary. We should remove it. Nobody removes. It becomes legacy. It's added complexity that will, in the end, benefit the attacker. So it would be cool if researchers were sharing a little bit more of this information so we can make better calls. One example of a company that is trying to change some of that is Microsoft, right? They trying to share some of what they see. Hey, we saw this percentage of exploits against browsers were used after freeze. In this percentage, any percentage actually don't work against browsers with this given mitigation. Those numbers are very cool, but they're only one source, right? And to be honest, since they don't give us the raw data, we need to choose if we trust them, right? But it would be interesting if all researchers were helping and creating that. So an example of a data that is very hard to find, doesn't matter where you work, is for example, what is the percentage of memory corruption exploits, for example, in Metasploit or available in the world, or for a given product, you can use whatever sentence you want there, right? That, for example, bypass ASLR. Or that bypass DEP, or that bypass CFG, canary protection, or whatever other mitigation you want to name, right? This is not a complete list. And the question is, for the ones that do not bypass, that do not take in consideration a mitigation is in place, why not? Do they need additional bugs to actually bypass it? So for example, they don't bypass ASLR because it does require an info leak, or the researcher was just lazy or didn't care or whatever. This was just a POC to talk about the vulnerability. It was not really to demonstrate like the full impact or the full-blown scope of that vulnerability. So this is very hard to find. You don't have an easy way to get that data. And without it, like when we say, hey, yes, this mitigation helps, what data are we using to really claim it helps, right? So I really hope that like as researchers, we can start providing some of this, or someone can try to go and do the work of like trying to collect some of those and make those available. Notice it's very hard. If the researchers didn't really actually provide it originally, then that means you really need to understand in the full scope of that vulnerability to actually be able to characterize that. So it's a huge research ask. So it is not easy to come up with that. And without it, it's very hard to help in mitigation engineering. So I work for a hardware company. Imagine that I say, hey, yes, like I could go and create a new hardware primitive that would help. Would help what? There is no data that I can even use to make that claim. And if I can't have a data to make the claim, that basically means I need to convince someone to say that they will adopt whatever I say I will implement. And if I need to convince someone to adopt, that means they need to consider their own business needs and business cases, and they will use their own information. So it's much harder to actually propose something that will change and that will be adopted, right? Because the data is just not available. So going back to the importance of formalization, right? And here, it also ties back to data, right? As more as we add some formality, as more as we transform this from art to something that is really engineering, as more as this data will naturally be present, right? Because if we bring the academics, if we bring in the engineers, and they all come and start helping, they also bring their own methods, and they also understand the need for this data to be available. So we start making a really big transformation in the entire industry, right? Not only having more talent to help, but also having more people with a method where hackers historically, or because of artists, right, don't really care too much about necessarily the method, which doesn't mean that they don't understand. It's just that the approach for the problem is very different, right? So I want to say that there is a trend there, right? There is a trend in formalization, and we can see that, right? We can see that there is a lot of work coming in the recent years on trying to formalize what is an exploit, to try to formalize how a mitigation applies into a system, to try to even formalize security. And I think LangSec is one of these good works that are coming there. But even though there is some work coming, they are all coming from practitioners, from people that actually work doing the writing exploits, writing the code, not really coming from the academics, unfortunately. So we still need to bridge that gap. Another point is, as more as we formalize, as more as we have a better understanding, and as more as we try to transform this artistic work in the engineering, we will have some conflicts. Some things that a guidance from one doesn't match with the traditional guidance. I will cite two examples that we see with LangSec, right? LangSec, if you consider it, it talks about recognizers, really having the parser that fully understand what is the input before letting this input go inside of your big complexity of code that use this input. It talks about simplifying the input in a way that you can actually recognize it. So LangSec is very powerful, and it's really a revolution in security. But if you look, for example, comparing it with what is the traditional guidance in secure development, you have some things there that don't match, right? In current secure development guidance, we talk as a rule, right? It's hey, check the input as close to where it's consumed as possible. That basically means that the input is checked in the middle of somewhere in the code or in the middle of somewhere in the hardware, because that's where that input will be used. While LangSec tries to say that essentially you need to consume input and recognize it and parse it as close as possible to where you receive the input. So it's completely different ways of doing that, right? And secure development defined it as to be as close as possible for good reasons, right? You wanted to avoid the famous copy and paste of bugs, right? You go, like there is a code somewhere, like it's copied somewhere else, or there's a function that's leveraged somewhere else in the code, and the function used to be secure. Now, because you put it in a different path, it's not secure anymore. But then, like, the truth is, there is ways to make them compatible. There is, of course, ways. The only matter is, like it will take time. And that's just like basic rules in secure development, right? The first one is really like having the input checked as close as to where you use, and the second one is having intrinsically secure functions. They're basic rules. Imagine when like this, like the entire LangSec, the entire formalization outside also of LangSec evolves, more things that are traditional will be understood as, hey, maybe that's not the ideal, or that's not the most secure way of doing things. So we're changing the way that engineering happens. So we need to be fast, right? Because we know that if we change now that rule, it will take, what, 15 years for the whole industry to really adopt it, to really understand? So it's better that we do it as fast as possible, right? Otherwise, we will keep having the problems. As I mentioned, right, there are other work in formalizations, right? Like, and those work, I really want to cite and refer because they are very important work. So one is like by Julian Vanige. So he started modeling heap, or heap implementation, right, the heap algorithms. It's interesting because this work, like really, like he started it before DARPA had the initiative on automated exploitation, and he took as a challenge, hey, can we really automate exploits or the generation of exploits? And the very first requirement is for you to actually be able to model how the algorithm works, then you can model how you can abuse the algorithm to create a given state, and then you can model if you get the primitives that you need for a successful exploit. So this work for me, it's very good. It's very revolutionary. It's still in early phases. Like he presented a new version recently on the LangSec workshop, but I recommend people to pay attention into it. Another one is like a more recent paper by Halvard Flake, where he tries to define what is really doing like a vulnerability, right? Like how really like an exploit work. Right? He tries to create that framework, like to add this formality, so to make it easier for non-practitioners or people that don't really write exploits for as a way of living to basically better understand and get together. I also believe this is a very, very important work. It's still like an incipient thing. There's a lot of limitations there, but I do recommend people to have a look. It's also important to notice that like this complexity, this idea of like, hey, formalizing complexity and trying to better look into problems in a different angle, it's not unique to security. Another day, now at this point a while back, I saw then like a sentence in a blog post about compression. I was looking for, like, it was a vulnerability in a compression algorithm, so I was trying to understand the compression algorithm. And basically then like, look into the blog post, like it's really just a blog post. The guy say, a modern compressor is a bit like a compiler. The compressed data is a kind of a program in bytecode, and the decompressor is just an interpreter that runs that bytecode. It's very interesting, right? Because it goes very close to the definition that like LangSec tries to say that, hey, data is what drives code, right? It's the input of like a program that actually drives the directions of that program. So I found it phenomenal to see that other areas are also trying to formalize some of this complexity, and some of the terminology ends up merging. Obviously, I also say that like practitioners, right, like hackers, they are artists. That means that they already knew some of it, right? Or maybe all of it, to be fair, like all of it, right? So there were early attempts of trying to formalize something. So for example, I like to cite this work by Jera at the time at Core Security. Jera, by the way, is a phenomenal exploit writer, where he started defining what are primitives. So it's very interesting because then, like, it's like very early work on it, but then like he tried to transform the writing of an exploit in something that is just a normal engineering process, and how you think about that as an engineering process. So it's one of the early works there. Microsoft recently has been made some series of presentations where they talk about, hey, those are the exploit numbers that we see, and here's what mitigations this is driving. So recently they made a presentation in Blue Hat in Israel where they explained that, hey, those are the hardware attacks that we are seeing, like physical attacks, and these are the mitigations that are like we are now leveraging because of those hardware attacks. So I like that. And another thing is, a lot of formalizations that come from the academia, in the end, they were already known. ROP is one of the very famous examples, right? Like people used returning to libc and actually used multiple instances of returns, which is essentially ROP, and used gadgets even long before it was formalized. But after it got formalized, many more work actually started coming, many more tool settings started being developed, and much more engineering started appearing on top of this. So I think like the formalization is something that it's beneficial. And a while back, really long ago, I had a professor in computer math, named Soma, and in the class breaks, we used it to play chess. He loved to play chess. And that professor was amazing, right? And then one day, he asked me, hey, what do you do for a living, right? And at the time, I worked as an exploit writer. So I said, yeah, I'm an exploit writer, as if it means anything for someone who's not really in the computer field, right? So he was like, hey, explain me what it is. And I tried to explain, tried to tell him why a company would pay me to write an exploit, how exploits had value. And he found it fascinating, as usually people find it fascinating. But then he basically challenged me. He was like, hey, I think you need to better explain your work. You are not doing a very good job doing it. So define your work using set theory. And at the time he was really into set theory. So he really wanted me to try to do something like that. So I did it. I presented him after a couple of months a model. But then I really didn't give any importance to that model. I literally threw it away. I didn't care about that. I didn't think it was important. I was very ignorant, to be honest. But then along the years, every time that people came to discuss with me about mitigations, vulnerabilities, primitives, what they are, how do you do, how you group them together, I always brought back this idea of hey, let me put it as a set. Let me define the set. Let me put to you how we actually bundle things together, how multiple vulnerabilities can be used by only one exploit, how the final objective can leverage multiple vulnerabilities to get into it. So I tried to use that along the time. And when I presented it to some of my teammates, they loved it. They were like, hey, we need to write a paper on it. So we recently released the paper in LangSec conference. So those are the three teammates that worked on it with me. So sorry, actually their names are the most important part. So Kekai Hu, Ki Sun, and Enrique Kawakami. So after that, what we tried to define in this paper was essentially what is really an exploit, what an exploit comprises, how you bundle things together, and where mitigation fits. So this is what we try to define in the paper. So the paper is available. I recommend folks to have a look into it. But one of the things, for example, that we define there is that exploit primitives exist, and they have basically two elements that define them, right? Their type, it's a read, write, or an execute, and the primitive properties that we basically stole from Paxton presentation in Brazil. By the way, I don't know, but I think the majority of people here notice that I keep referring to PAX, and PPatch is actually from Hungary, right? So be proud of the accomplishments of him. So in this paper, we define it, what are the conditions and all, so all the formulas are available. I will not get into the details. But one of the things that we also try to argue on the paper is the difference between a probabilistic and a deterministic mitigation. And it's actually interesting because when we working on the definition, right, as more as you try to formalize something, as more interesting corner cases come to your mind, right? So one that is actually common to see in discussions is, imagine you have a data, the data is at rest, you're just encrypting the data, later on you might go and decrypt the data. You're encrypting with, I don't know, AES 256. Consider state of the art in encryption or whatever, right? Assuming no quantum computers, assuming no breakthrough in computing power, right? Good. Do you consider that encryption a deterministic mitigation against that data that is just laying there being stolen or not? Or it's a probabilistic because there is still a chance that there was some problem happening there. So we argue that the proper use of encryption can be considered deterministic. And we argue that probabilistic is something that really, in real life, in normal, like assuming that the implementation is good, the attacker is still able to break it given a number of tries. Even if it's not very practical, because the system might have other things in place, like ASLR might have, like, for example, something that avoids the process from spawning in place. But then, like, this is what we consider probabilistic. While doing like an encryption, like a properly implemented encryption, might be considered deterministic. But notice how corner cases make a huge difference. And again, bringing back my point on the difference between the implementation and just the architectural design of something. If you don't consider the data to be at rest, for example, imagine you have like an actual memory encryption mechanism. So the data is now being consumed by the CPU. When the CPU consumes, the data is decrypted. And when the CPU actually does an update, the data is encrypted back. So in main memory, the data is always encrypted. In this case, if you use only encryption without authentication, you still have only a probabilistic protection. And then, like, we demonstrate that in another work with Shigeron, like a famous cryptographer, and where we demonstrated that if you just encrypt the main memory, but you don't use authentication, basically you have a probabilistic mitigation. Again, demonstrating that the implementation is what is more important in a mitigation, much more than actually only what is architectural. And basically, like, to conclude, like, I bring back the 3 points that I made in the beginning that I really hope, if you remember only 3 things on this talk, those were the 3 things. If there is a new vulnerability mitigation trying to address a class of vulnerabilities, let's hope it fully mitigates at least 3 instances of this class. Those proposing mitigations, they must really understand the problem. That can happen either by actually writing exploits or pairing with someone who does, right? And the third, investment in defense should benefit from the investments in offense or be guided by it. So in the mitigation space, implementation details really make a lot of difference. So only the architecture definition is not enough. Thank you.